Hi guys, today's video we're going to do the summary of chapter 6, which is network layer. Then here's the um, a little bit presentation about this chapter. So let's start. So chapter 6, network layer. So network layer is um, network layer protocols. So there are several network layer protocols in existence. So however, uh, there are only network layer protocols that are commonly implemented. So it's the IPv4 and the IPv6, or Internet Protocol version 4 and Internet Protocol version 6. So there's a note that legacy network layer protocols are not shown and are not discussed in this in this chapter 6. So encapsulating IP. So IP encapsulate the transport layer segment or other data by adding an IP header. So this header is used to deliver the packet to the destination, and it's used to deliver the packet to the destination host. The IP header remains the same from the time the packet leaves the source of host until it arrives at the destination host. So the next one is the characteristic of IP. So IP was designed as a protocol with low overhead, and it provides only the function that are necessary to deliver a packet from a source to a destination. So over an interconnected system of networks, the protocol was not designed to track and manage the flow of packets. So this function, if required, are performed by other protocols at other layers. So primarily the TCP, or the transmission control protocol at layer 4. So the basic characteristic of IP are uh, described in chapter 6. So the next one is the IPv4 packet header, or Internet Protocol version 6 packet header. So an IPv4 packet header consists of field containing important information about the packet. So these fields contain binary numbers which are examined by the layer 3 process. So the binary values of each field identify various settings of the IP packet. Protocol header diagrams, which are read left to right and top down, provide a visual refer to when discussing protocol fields. So the IP protocol header diagram in the figure identify the fields of an IPv4 packet, significant fields in the IPv4 header. So the next one will be the introducing of Internet Protocol version 6. So in the early 1990s, uh, the Internet Engineering Task Force, or IETF, grew concerned about the issues with the Internet Protocol version 4. So then it began to look for a replacement. So this activity led to the development of IP version 6, or IPv6. So IPv6 overcome the limitation of IPv4 and is a powerful enhancement with features that is better suit current and foreseeable network demands. So the next one will be the default gateway. So the default gateway is the network device that can route traffic to other network. So it is the router that can route traffic out of the local network. So if you use the analogy that a network is like a room, then the default gateway is like a doorway. So if you want to get another room or network, you need to find the doorway. So that's the default gateway. So the next one will be the next hop address. So when a packet destined for a remote network arrives at the router matches the destination network to route in routing table. So if a match is found, the router forwards the packet to the next hop address out of the identified interface. So the router is a computer. Okay. Then the next one is the router CPUs and OS. So like all computers, tablet, gaming consoles, and smart devices, Cisco devices require a CPU to execute operating system instructions such as the initialization, routing function, and switching function. So the highlighted components of the CPU of a Cisco 1941 router with the heatsink. The heatsink help despite the generated by the CPU. So the router memory. So a router is accessible volatile or non-volatile memory storage. So volatile requires continual power to maintain its information, and then when the router is powered down or restarted, the content is erased and lost. So non-volatile memory retain its information even when a device is rebooted. So specifically, a Cisco router uses four types of memory, which is the RAM, ROM, NVRAM, and flash. So first, the RAM. This is a volatile memory used in Cisco router to store application and processes and data needed to be executed by the uh, CPU. So Cisco router use a fast type of RAM or random access memory called synchronous dynamic random access memory or SDRAM. Then the next one is the ROM. So this non-volatile memory is used to store crucial operational instruction and a limited IOS. Specifically, ROM is a firmware embedded in an integrated circuit inside the router which can only be altered by Cisco. So the next one is the NVRAM or non-volatile RAM. So this is non-volatile memory is used as a permanent storage for the startup configuration file. So that's the startup config. Then the last one is the flash. This non-volatile computer memory used as permanent storage for the iOS and other system related files such as big files, log files, voice configuration line, files, HTML files, backup configuration, and more. When router is rebooted, the iOS copied from the flash into RAM. So the next one will be the LAN and WAN interfaces. So the connection on a Cisco router can be grouped into two categories: in-band router interfaces and management port. Click the highlighted. So similar to Cisco, there are several ways to access user exit mode in the CLI environment or a Cisco router. So there are the most common is the console, the secure shell or SSH, and the telnet. So the first one is the console. So console is a physical management for that port provides out of band access to a Cisco device. So out out of band access refers to access via a dedicated management channel that is used for a device maintenance purposes only. So, SSH or secure shell is a method for remotely establishing a secure CLI or command line interface connection to a virtual interface over a network. Unlike a console connection, SSH connection require an active networking services on the device, including an active interface configuration with address. So the last one is the telnet, which is an insecure method of remotely establishing CLI session through a virtual interface over a network. Unlike SSH, Telnet does not provide a securely encrypted connection. So user authentication, password, and commands are sent over the networks in plain text. So the last one will be the botset files. So both Cisco and routers and switches load the iOS image and start a configuration file in RAM when they are booted, as shown in the figure. So the running configuration is modified when the network administration performs device configuration. Changes made to the running config should be saved start a configuration file in NVRAM in case the router is pristine or lose power. So let's go to the NetAcad. So chapter 6 summary for the NetAcad is the network layer or OSI layer 3 provides service to allow end devices to exchange data across the network. So to accomplish this end-to-end transport, the network layer used for basic processes, IP addressing for end devices, encapsulation, routing, and encapsulation. So the internet is largely based on Internet Protocol version 4, which is still uh, the most widely used network layer protocol. So an IPv4 packet contains the IP header and the payload. So however, IPv4 has a limited number of unique public IP addresses available. This led to the development of IP version 6. So the IPv6 simplified header offers several advantages over IPv4. So including better routing efficiency, simplified extension headers, and capability for per flow processing, plus IPv6 addresses are based on 128-bit hierarchical addressing as opposed to IPv4 with 32 bits. So this dramatically increased the number of available IP addresses. So in addition, the hierarchical addressing, the network layer is also responsible for routing. So hosts require a local routing table to ensure that packets are directed to the correct destination network. So the local table of a host typically contains the direct connection, the local network, and local default route. The local default route is the route to the default gateway. So default gateway is the IP address of a router interface connected to a local network. When a host needs forward the packets to a destination address that is not on the same network as the host. So the packet is sent to the default gateway for further processing. So when a router such as default gateway receives a packet, it examines the destination IP address to determine the destination network. The routing table of a router stores information about directly connected routes and remote routes to IP network. If the router has an entry in its routing table for the destination network, the router forwards the packet if routing entry exists. The router may forward the packet to its own default route if one is configured, or it will drop the packet. So, routing table entries can be configured manually on each router to provide static routing, or the router may communicate route information dynamically between each other using a routing protocol. So in order for router to be reachable, the router interface must be configured. So to enable a specific interface, enter interface configuration mode using the interface command type and number global configuration mode command. So now that we have done in a summary of chapter 6, this video will end, and hope you learned something about this video, and thank you for watching.